Okay. So in the first question, find the area of a quadrant whose perimeter is 25 centimeters. Find the area given perimeter of a quadrant. So you can see the figure here. A quadrant is a sector whose sector angle is 90 degrees. A quadrant is a sector whose sector angle is 90 degrees. Quadrant we know is 1/4 of a circle. 1/4 of a circle is a quadrant. And a quadrant is also a sector because it's bounded by two radii, OA and OB, and an arc, AB. So the perimeter of the sector is given to you. Now, what makes the perimeter of the sector? The sector is made up of, the sector or the quadrant is made up of two radii, OA and OB, and an arc AB. So you can see here I've marked, this is R, and this one, the length of the circle or the circumference of the circle is 2 pi r. 1/4 of that is in the quadrant. 1/4 of this length is in the quadrant. 2 pi r is the total length, the circumference of the circle. 1/4 of that is here. From here to here is 1/4 of the length of the circle. So 1/4 into 2 pi r. So 2 1s are, 2 2s are. So it's pi r by 2. That's how we get pi r by 2. This one is pi r by 2. That's how we get pi r by 2. Because see, complete the circle. Complete the circle. This is the circle. This is a circle. And here is 1/4 of 2 pi r. Okay. So the perimeter of the quadrant is 25. Perimeter is OA plus OB plus length of arc AB is 25. So R plus R plus 2 pi r by 4 is equal to 25. So you know, you can work this and find the value of R. Work this and find the value of R. Now find the area of the quadrant. The area of the quadrant is 1/4 the total area, 1/4 into pi r square. Or you can also use the formula 90 by 360. 90 by 360 into pi r square, because theta by 360 into pi r square. Theta is 90 by 360, which simplifies to 1/4. 90 by 360 is 1/4. It reduces to 1/4. 1/4 pi r square. That's about the first one. So you'll have to take care about, interpreting perimeter. You should not misinterpret that. Perimeter is the length of the boundary. Sometimes we understand perimeter to be only this length. We understand perimeter to be only this length. No, perimeter is the length of the boundary of a closed region. Perimeter is the length of the boundary of a closed region. Quadrant is a closed region. It's closed. It's enclosed by two radii and an arc. The length of this boundary is 25. Not only this length. This is the length of the arc in the quadrant. This is the length of the arc in the quadrant. Perimeter of the quadrant is this one plus this one plus this one. Perimeter, the length of the boundary. All right. So that's about the first one. Here we have to find the number of revolutions. Since you've already read the question, I'm not reading it again for you children. So now the distance covered by the wheel, the distance covered by the wheel in one revolution is equal to the circumference of the wheel. Distance covered by the wheel in one revolution is equal to the circumference of the wheel. So 2 pi r is the distance covered in one revolution. Okay, 2 pi r is the distance covered in one revolution. And now here we know the diameter 80, so radius is 40. So we can find the distance covered in one revolution. We can find that. Now, What is the total distance covered? That also we can find because we are given speed and time. We are given speed. Speed is equal to 66 kilometers per hour and time 10 minutes. Time 10 minutes. But you need to convert minutes to hours because speed is in kilometer per hour. So you need to convert minutes to hours. So 10 minutes meaning 10 by 60 or 1/6 of an hour. This is the time. 1/6 of the 1/6 of an hour is a time. Speed is 66 kilometers per hour. So using these two, you can find the distance covered. So the distance covered is equal to, you know, the formula speed into time. Distance is speed into time. We need to take care of the units. Speed is in kilometers per hour. So time also should be in hours. Now the distance you get will be in kilometers because speed is in kilometer per hour. So the answer you get for distance, the unit will be kilometers, not centimeter. The diameter is 80 centimeters. So don't think the distance will be in centimeters. No. How are you finding the distance? Using speed and time. In speed, what is the unit we have for distance? Kilometer. So 66 is the speed, time is 1/6. So on simplifying, 11 kilometers. Because in speed we have kilometers. So 11 kilometers is the distance. Now when you find the 2 pi r, I'll just copy the answer from here. What do you get? 2 pi r, 1760 by 7 centimeters. 2 pi r is 1760 by 7 centimeters. Okay. Now we have to find the number of revolutions. We have to find the number of revolutions. So the number of revolutions will be the total distance by the distance covered in one revolution. Okay. So 2 pi r is the distance covered in one revolution. Okay. So the distance covered in one revolution, 2 pi r, into the number of revolutions will be the total distance covered. You can also understand like this. The distance covered in one revolution. What is the distance covered in one revolution? 2 pi r into the number of revolutions. That will give you the total distance covered. The total distance covered by the wheels will be the distance covered by the wheel in one revolution into the number of revolutions. Into the number of revolutions the wheel makes. So 2 pi r into number of revolutions is equal to the total distance covered. So what's the answer for 2 pi r? 1760 by 7. See, you should write circumference. I've just written 2 pi r to understand. Okay, so 1760 by 7. This in centimeter, children. Into the number of revolutions is equal to the total distance, 11 kilometers. So convert kilometers to centimeter. So kilometer to meter, you'll have to add 3 zeros. And meter to centimeter, 2 zeros. See, kilometer. Kilometer to meter, 3 zeros. Now this meter to centimeter, 2 zeros. Centimeter. When you work this, you will find the number of revolutions. So just remember this equation, children. Sometimes, you know, this question I've seen is confusing for many children to, comprehend and work. They do something, finally they get the answer. Something which is to be done in 2-3 steps, is done very elaborately. That's because there is some confusion. We are not clear about the procedure or we are not clear as to how to use this information. Just remember this equation, this formula. Okay, this will help you. Circumference into number of revolutions will give the total distance. That's all. So can you find the circumference? Yes, because we know the diameter. Number of revolutions we have to find. Total distance can we find? Yes, because we know speed and time. That's all. You remember this formula. Circumference of the wheel into the number of revolutions the wheel makes is equal to the total distance covered by the whatever vehicle. So circumference can be found if you know the radius or diameter. Okay. Total distance can be found when you're given parameters like speed and time. So in this case, both can be found. So when one find that and then find the number of revolutions. So in this equation, two things can be found, circumference and total distance. So find the third one using this formula, number of revolutions. That's about the second one. So find the area of the face of the clock. Find the area of the face of the clock swept by the minute hand 12 centimeters long in 35 minutes. In 35 minutes. Clock. Supposing the time now is 8 o'clock. We are not drawing the hour hand. We're going to draw only the minute hand because the question is about the minute hand. We're not going to show the hour hand. Only the minute hand we are going to show. All right. Now, when the clock shows 8, the minute hand is at 12. The minute hand is at 12. The hour hand is there, but it's not in our figure, that's all. When the clock shows 8, the minute hand is at 12. Okay. Now the minute hand goes 35 minutes. So 8:35 it is. So where this is the initial position of the minute hand. Now after 35 minutes, so it's going to come here. So it's going to come here. So it's traced this sector on the face of the clock. It's traced this sector. See, it will not touch this boundary of the clock. Whatever is the radius of the minute hand. In fact, the clock can be triangular. It can be a triangular clock also. But the minute hand, the hands, they will always sweep circles. The hands will always sweep circles. The hands, the hour hand, minute and seconds hand, they'll always sweep circles. The clock will have any shape. So if it's a triangular clock, not that they'll trace triangles. Because the hands are fixed to the center, they can only trace a circle. So the minute hand is at 12. It moves in 35 minutes. It moves and it comes to 7. So this is the area. It would have swept in going 35 minutes. This region is swept by the minute hand. This is a sector. You can see this is the center. This is the radius. This is also the radius. Radius, radius. And this is the arc. And this is the area. This is the area of the face of the clock swept by the minute hand in going 35 minutes. The radius is given. The length of the minute hand is the radius, 12 centimeters. Radius 12 centimeters. And this is how the sector looks like. See, it's bounded by 2 radii and an arc. You need to find the area of the sector. And we know to find the area of the sector, we need the sector angle. We need the sector angle. See, you can do it without the sector angle also, but we'll find the sector angle. We'll learn how to find the sector angle. You can do it even without finding the sector angle, but we'll learn how to do it with the sector angle. Now, for that, I normally use a proportion. Now, use the proportion like this. The minute hand. How many, like in how many minutes will the minute hand go 360 degrees? In how many minutes? We are talking about the minute hand. So in how many minutes will the minute hand go 360 degrees? So 360 degrees meaning the minute hand is at 12. The minute hand is at 12. When will it come back to 12? Because it starts at 12. It has to come back to 12 to go 360 degrees. To go 360 degrees, if it starts at 12, it has to move and come back to 12. And the minute hand will take 60 minutes to sweep the face of the clock once. To make one complete circle, it will take 60 minutes, the minute hand. So in 60 minutes, it goes 360 degrees. Then in 35 minutes, it will go how many degrees? X degrees. First, you write the general thing. Then you write what the specific one, what you want to find. I'll write it again. In 60 minutes, the minute hand covers 360 degrees. Then in 35 minutes, what is the degree it will cover? You can also write it like this. It goes, the minute hand goes 360 degrees in 60 minutes. Then how many degrees in 35 minutes? So writing the proportion is correctly is very important. If you write this order, degree, minutes, then you should write degree, minutes. If you write minutes and degree, you should write minutes and degree. On the two sides, you know, the order should be the same. Otherwise, you will go wrong in getting the value. If you write minutes and degree in the first part, the second part also you should have minutes and degree, that order. So now we know that product of means is equal to product of extremes. Product of means is equal to product of extremes. So product of means 60 into x is equal to product of extremes, is equal to 360 into 35. Or if you write like this, product of means 360 into 35 is equal to 60 into x. You get the same answer in both. So like that, you should find the sector angle. And once you find the sector angle, that angle by 360 into pi r square will give you the area of the sector. So that's what you see here. That proportion is what you see here. And then product of extremes is equal to product of means. Anything you can write first. Product of means is equal to product of extremes, or product of extremes is equal to product of means. Anyways, so use this and find the sector angle and then find the area. Now, supposing it's about the R hand. Supposing it's about the R hand. Class, use the emoji, raise your hand. Florentina, Sri Ranjan, Prajit, Madhumita, Ritika, Rakshita, Arjun, Navya, Sri Krishmi, Raja, Danya, Dileepan, Danya. Are you there, Danya? Yeah, okay. All right, Danya, fine. Very good. All right, children. So, did I see Raja? Second. Yeah, you're there. All right, children, fine. Now, supposing this question was about the R hand. R hand. Now, tell me, children, how long does the R hand need to go 360 degrees? Answer this question. How long the R hand needs to go 360 degrees?
1 hour. 12 hours, ma'am. 12 hours, ma'am. 12 hours, ma'am.
12 hours. 12 hours. Okay. So now, okay, say now it's 9 o'clock. Okay, it's 9 p.m. Okay, it's now 9 p.m. This is the R hand, okay? It's now 9 p.m. When will this R hand come back to 9? The minute hand will come back to, the minute hand now is at 12. At 9 o'clock, the minute hand is at 12. The minute hand will come back to 12 at 10 o'clock. At 10 p.m. it will come back to 12. So the minute hand just needs 1 hour. That is 16 minutes to go 360 degrees. Talking about the R hand at 9 o'clock, 9 p.m. is at 9. So it should come back to 9. The R hand should go, we should complete a circle. So the R hand like this, it will come like this. It has to go all the way like this, like this, like this, and come back to this position. This position. So when will the R hand come back to 9? At 9 a.m. next day, tomorrow. So what is that duration? 12 hours. So the R hand needs 12 hours to go 360 degrees. 1 hour, x degree. Like this, whatever is the question, whatever is in the question. 12 hours, 360 degrees. So 1 hour, how many degrees? Or 2 hours, how many degrees? 3 hours, how many degrees? Whatever is the requirement, you'll have to use here. This is the proportion. If it's the hour hand. If it's the hour hand, this is the proportion. You can just make a note of this. Just write it neatly again. Please make a note of this. This is about the hour hand. This is the proportion you need to use if the question talks about the hour hand. The hour hand goes 360 degrees in, or I'll write it like this. 1 second. The hour hand needs 12 hours to go 360 degrees. Then in 1 hour, how many degrees? Okay, so this is about the hour hand. If you need to compute about the hour hand. Supposing seconds hand, the seconds hand. When will the seconds hand come back to 12?
1 minute.
In 1 minute. It just needs 1 minute. In 60 seconds. 60 seconds it will come back. So the seconds hand, it goes in 60 seconds, it goes 360 degrees. So in whatever seconds, in 20 seconds, 30 seconds, whatever you have to find, you know. So the seconds hand, so this proportion will be very useful to find the sector angle. See, each of the hands, they trace mostly the 3 hands. See, the hour hand is the shortest. The minute hand and the seconds hand, I'm not really sure, but I think all of them have different lengths. The seconds hand is the longest, but I don't know today how the clocks come. But anyways, the shortest hand is the hour hand. The shortest hand is the hour hand. Now, assuming that all the 3 hands have different lengths, so they are tracing 3 concentric circles. They have the same center. All the 3 are fixed to the same center. They trace 3 different circles. So they are tracing concentric circles. The hour hand, the minute hand, and the seconds hand, as they move, they trace circles. They have the same center, but they have different lengths or different radii. So the circles traced by these 3 hands are concentric circles. Okay, seconds hand, it just needs 60 seconds to go 360 degrees. Then say like in 6 seconds, how many degrees? X degrees. So this is how you find the sector angle when it comes to a question based on a clock. Yeah, please make a note of this, children. Yeah, is it over?
Yes, ma'am.
All right, thank you. That was about this one, the third one. Now, so here hectare is a unit for area. Hectare is a unit for area. 1 hectare, short for hectare is HA, not HE. HA is short for hectare, not HE, HA. 1 HA means 1 hectare. Has an area of 10,000 meters square. 10,000 meters square is equal to 1 hectare. An area of 10,000 meters square is equal to 1 hectare. Okay. All right. Now in this question, find the length of the diagonal of a square whose area is 0.5 hectares. So 1 hectare is 10,000 meters square. 0.5 hectares will be 0.5 into 10,000, which is 5,000 meters square. So I think this you would have done it. Meaning You've done everything, but this one looks simple. So areas 5,000 meters square. And we need to find the length of the diagonal. What's the formula to find the length of the diagonal? Root 2a. Area is equal to 5,000 meters square. Diagonal root 2a. Now area is 5,000, meaning side square. Side square is equal to 5,000. So side is equal to square root of 5,000, correct? Side is equal to square root of 5,000. Now diagonal, length of the diagonal. Diagonal is equal to root 2 into side, root 2a, root 2 into side. So root 2 into root 5,000. So it is root of 10,000, which is equal to 100 meters. I don't know how I worked it here. Okay. Okay. That's what it is. Okay. So area is 5,000 meters square. So side square, area means side square, is 5,000. So side is square root of 5,000. Now diagonal, this is the formula. I've used the other formula also, half d square for area of square, that is. That's the formula to find the area of a square using the diagonal. Half d square. Half d square, what I've used here. Half d square is the formula to find the area of a square given the length of the diagonal. If the length of the diagonal is given to you, area of the square can be found using the formula half d square. That's what I've written there, half d square. D is the diagonal. Okay. Yeah, you can also do it like this. So side is root of 5,000. Diagonal formula is root 2 into side. So root 2 into root 5,000, root 10,000, which is 100 meters. All right. This one also I have nothing much to say about this. You'll have to be careful about when it is perimeter of the sector. Don't forget to, or don't think it's only this one. Perimeter of sector is not only the length of this one. Sector. So how does a sector look? It's bounded by 2 radii and 1 arc. So perimeter meaning this, the length of this line segment plus the length of this line segment plus the length of this arc. All this put together is 68 perimeter. So normally we call this one L, length of arc, L. Not one, that's not one, children. There's not one. Length of arc, L, L, length of arc. So perimeter is 68. So this one is 68. So you get L is equal to 40. L is equal to 40. Now area of sector, I've given you this alternate formula also. When you know the value of L, area of sector is equal to LR by 2. Or maybe your teacher has told you half LR. Both are the same. Half LR or LR by 2. Where L is the length of the arc in that sector, not the length of any arc. That sector has an arc attached to it, right? The length of that arc. If you want to find the area of a sector, that sector has an arc attached to it. The length of that arc into radius divided by 2 will give you the area of the corresponding sector. So LR by 2. L is 40 into R 14 by 2. I think this is just Pythagoras theorem. And then, sorry, this is just trigonometry. This I told you last class. I think in some 2-3 situations, I kept repeating. If you need to find a missing angle or missing side in a right triangle, think trigonometry. So I'm not taking your time doing this again. Find the area of the largest triangle that can be inscribed in a semicircle of radius r. So the largest triangle should have the largest base and the largest height. the largest triangle that can be inscribed in a semicircle should have the biggest base and the biggest height. So that triangle will have the biggest or the largest area. So the maximum possible, in a semicircle, the maximum possible base in a semicircle, the maximum possible base is the diameter. The maximum possible height is the radius. So the area of this triangle. See the shape of the triangle. So I'm saying that that triangle which has diameter as the base and the radius as the height will be the area of the largest triangle. So the triangle which has the diameter as the base and the radius as the height. So what is it? Half into radius is so half into base into height, half into base 2r into height r. So 2 gets cancelled. So the answer is r squared. R squared square units. So that's about it. Yeah, we'll do this one. I think most of this you can do it. Okay, I'll share this as assignment. 1 second. Yeah, children, please take screenshots of this one. Do this as assignment. 1 second. Yeah, please take a picture, children. Homework. Dear children, the question, find the number of rounds. So that means number of revolutions. So now, so when you see a question like this, what's the formula? Circumference into the number of revolutions is equal to the total distance covered. Circumference into number of revolutions is the total distance covered. So you can find the circumference. So see, different places would have worked differently, but the idea is the same. This is the formula. Circumference into number of rounds is the total distance. I've written the formula itself. Now circumference is 2 pi r. Number of rounds, total distance. Here, 4 kilometers. So it's easy. I'll not start explaining this again. So that's what it is. But just take care about the units. This is in meters. And here the diameter is also in meters, but the distance was given in kilometers. So you have both in the same unit. This one is in meters, so convert this also to meters. That's very important. Watch out for the units. The units must be same throughout the equation. Yeah, taken a picture. Children, only if you respond can I proceed. Have you taken a screenshot?
Yes, ma'am.
Okay. This is the second one.
Taken.
Yeah, thank you. I like that. Please acknowledge it. It's so rude to just keep going. At least one of you, if you acknowledge. Yeah, this is the third one.
Taken.
Somebody wants a second one? This is 2. This is 3.
Taken.
Yeah. Yeah. This is the next one. Yeah. So here I'll have to tell you something, children. Now we know that the sum of the 3 angles of a triangle is equal to 180 degrees. Quadrilateral is 360. Now this is a hexagon. Okay. The sum of all the angles. Now angle A plus angle B, angle A plus angle B plus angle C plus angle D plus angle E plus angle F. The sum of these 6 angles. What will be the total? What will be the what is the angle sum property in a hexagon? Somebody said the door, children. I'm so sorry. I'll just come back. Have a look at the answer. I'm just coming back. Yeah. Thank you, children. Yeah. So the sum of all the angles, the sum of all the interior angles of a hexagon can be found using the formula 2n minus 4 into 90. This is the expression used to find the angle sum property of any polygon, of a polygon with n sides or n angles. Because we know if a polygon has 4 sides, it has 4 interior angles. 5 sides, 5 interior angles. 6 sides, 6 interior angles. To find the sum of all the interior angles of any polygon, 4 sides, 5 sides, 6 sides, 7 sides, 8 sides, you can use this expression 2n minus 4 into 90. So a hexagon has 6 sides. So 2 into 6 minus 4 into 90. 2 into 6 is 12. 12 minus 4, 8. 8 into 90, 720. 720. So the sum of all these 6 angles, angle A plus angle B plus angle C plus angle D, angle E, angle F is equal to 720 degrees. 720 degrees. So because you need to substitute that here. You need to substitute that here. Right? So this is of 8th standard. We have seen this in 8th standard. The formula to find the sum of all the interior angles of a polygon. 2n minus 4 into 90, where n stands for the number of sides or number of angles. Number of sides it is actually, but number of sides, number of angles, all are the same. So here a hexagon has 6 sides, so 6 angles, so n is 6 here. The others you can follow. Yeah, this is the next one, children.
Taken, ma'am.
Yeah.
Taken, ma'am.
All right. This we've already done. This one we've already done. I think we've worked this already, right? Just take a picture. You can check and then I've explained this. Just take the pictures.
Done.
Yeah. This is an alternate solution.
Done, ma'am.
Okay. Yeah. This one, I'll just talk about this now. Yeah. You'll do it as a part of the assignment, but let me just explain this. So here in this figure, you can see 4 half circles and 4 quarter circles. 4 half circles meaning 4 semicircles, and 4 quarter circles, sorry, and 2 quarter circles meaning 2 quadrants. 2 quadrants. 4 half circles, 4 semicircles, 2 quarter circles, 2 quadrants. So let's just check them first. So this is a semicircle, this one. This one is a semicircle. This one is a semicircle. This one is a semicircle. This one is also a semicircle. Okay, so this is a semicircle, children. That means AO is its diameter. This one is a semicircle. OD diameter. This one is a semicircle. So OC diameter. This one is a semicircle. So OB diameter. Now 2 quarter circles. This one. So OA and OD are the radii attached to the quadrant. OA and OD are the radii attached to the quadrant. Here, OC and OB are the radii attached to the quadrant. For the quadrant, OC, OB are radii. And for this quadrant, OA, OD radii. For the half circles or semicircles, the line segments attached to them are diameters. So we need to be careful while using the value of R. Now to find the area of the shaded region, the entire thing is shaded. The whole thing is shaded. So to find the area of the shaded region, you can see here, it is the area of the quadrant with radius OA. That's how you express. So see here, area of the quadrant with radius OA. So this is the quadrant with radius OA. Or you can say with radius OD also. OA or OD, whatever. Both are the same. So area of quadrant with radius OA. quadrant, quarter circle. So 1 by 4 into pi r square. And what is r? OA. And what is OA? 14. So see, 1 by 4 into pi r square, 14 into 14. Similarly, area of the semicircle with OB as diameter. So see this one. Semicircle with OB as diameter. Area of semicircle with OB as diameter. Semicircle. So what's the formula? Half into pi r square. Half into pi r square. And what is the value of r? It is half of OB because OB is a diameter. So radius will be OB by 2. 14 by 2, 7. So half into pi into 7 into 7. Now for the quadrant with radius OC, this one, this is the other quadrant. This is the quadrant. With radius, you can say OC or you can say OB also. Anything. So I've written OC. So quadrant with radius OC. Quadrant means 1 by 4 pi r square. And R is OC itself, which is 14. And then this semicircle. With this semicircle with diameter OD. Semicircle, so half pi r square. And OD is the diameter. So radius will be 14 by 2, 7. So you just have to be very careful in taking the values. This is what I am repeating time and again. If you go wrong in taking the values for R and D, all your efforts will go in vain. So we normally tend to become overconfident because very easy, just, it's like using half pi r square, quarter pi r square, you're going to get the answer. Be very careful here. So take the values carefully, use the right formula 1 by 4 pi r square or half pi r square and use the value of r carefully everywhere. Yeah. And this is how you, express or, make, this is how you, like identify the regions. You can either mark it as region 1, region 2, region 3, region 4 like this you can mark, or you can express yourself like this. Area of the quadrant with this as radius, area of the semicircle with this as diameter. So the area of the shaded region will be the sum of all these 4 things. Now coming to the most important part, perimeter. Perimeter, you'll have to just walk along the boundary or trace the boundary. Move your pencil over the boundary of the shaded region. Do not get inside the figure. Just move your pencil along the boundary of the shaded region. If you encounter a line segment, you should include that line segment. If you encounter an arc, then identify what the arc is. So since here it is all quarter circles or semicircles, you can find the length of the arcs easily. If it is the arc of a quadrant, it is 1 by 4 into 2 pi r. If it is the arc of a semicircle, it is half of 2 pi r. Because 2 pi r is the full thing. So if it is semicircle, if it is the arc of a semicircle, half into 2 pi r. If it is the arc of a quadrant, it is 1 by 4 into 2 pi. So let's begin. So we start here. OA plus length of arc AD plus length of arc DO plus line segment OC plus length of arc CB plus length of arc OB. That's it. We have come back to the starting point. So see here, it's like this. There's a line segment. Then there is a quarter circle. Then there is a semicircle. Then again a line segment, a quarter circle, and then a semicircle. Something like this it is. It's like this. You start from anywhere. You'll have to come back to the same point without getting inside the figure. without getting inside the figure. You should not take into account any line segment or any arc which is inside the figure. You're just walking along the boundary. So let's start from O. OC plus length of arc CB plus length of arc BO plus the line segment OA plus length of arc AD plus length of arc DU. See, we've come back to the starting point. We started at O and we came back to O. So this is what you'll have to find. So line segments, you have the length 14. Now for the arc in the quadrant, you must use 1/4 into 2 pi r, and the value of r, take it carefully. And for the half circles, you must use half into 2 pi r. Take the value of r carefully. That's all. This sum, add all these to get the perimeter of the shaded region. See, children, so that we understand better, I don't expect children to remember the formula directly like pi r by 2 and all that, because you have so much to remember, so don't do all that. You can write it. See, if it is for a quadrant, you can just write this is for the circle 2 pi r. So quadrant 1/4 into 2 pi r, and then you simplify. 2 ones are 2 twos are. So half of pi r. That's it. Yeah. So this answer has 2 images, 2 slides. Yeah. Take a picture now. In the first slide, it's about area. The second one is perimeter. Done, children?
Yes, ma'am.
All right. Yeah. Take a picture. This bar is length of line segment. Go back to 6th standard. This is how we write, no? Ray OA, line AB, line segment AB. So I've just used that bar here. Line segment OA, line segment OC. It's okay if you don't write that also. It's okay if you don't put this. It's okay. I've just written that to indicate line segment OA, line segment OC. Done, children?
Yes, ma'am.
Yeah. So this is the assignment. Yeah, children. Let's just you can work this later. It's pretty lengthy, this working, so that'll take up the entire class. I'll just tell you how to, like find you know it. But so that all of us, understand, so that I make sure that all of you know it, let me say. So again, here to find the perimeter, go along the boundary. It is the length of this semicircle plus 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 the length of this semicircle. All are semicircles here. All are semicircles. Even if it might not be given to you, then what else can we assume? It might not be given. They are all semicircles. So you start from any point. So see here, length of this semicircle, that is half into 2 pi r, half into 2 pi r, which is pi r. So it is pi r plus pi r plus pi r plus pi r plus pi r. We've come back to the starting point. Lengths of these line segments you should not use. Will not come. You have to go along the boundary of the shaded region. See here, we've gone along the boundary of the shaded region. So everywhere it is pi r plus pi r plus pi r. So you can write pi r1 plus pi r2 plus pi r3 plus pi r4. Now let's discuss the radius in each case. Now, what is the radius of this semicircle, children? What is the radius of the semicircle?
$3.5, ma'am.
3.5 or 7 by 2. What is the radius of this semicircle? Just tell me something by 2. Something by 2.
17.5 by 2.
17.5 by 2. Because what is attached to the semicircle is the diameter. Is a diameter. Diameter by 2. 7 plus 7, 14. 14 plus 3.5. 17.5 by 2. Okay, so then what is the radius of this semicircle?
3.5.
3.5 or 7 by 2. This semicircle, same thing, 7 by 2. And what about the radius of this semicircle?
10.5 by 2.
10.5 by 2. This semicircle, the radius of this semicircle, this is the diameter, 10.5 by 2. To find the area of this shaded region, will be the area of this semicircle minus the area of the semicircle. I told you for area and volume that subtraction will work, not for perimeter. For perimeter, you should not do perimeter of this one minus perimeter of this one. No. For area and volume, you can subtract. The bigger area minus a smaller area. The bigger volume minus a smaller volume. Now, to find the area of this region, it is the area of this semicircle minus the area of this semicircle. Will give you the area of this region. Have that. Now, the area of this semicircle minus the area of this semicircle will give you the area of this region. Now find the area of this semicircle. Find the area of this semicircle. Don't subtract or something. Just find the area of the semicircle. Now this answer plus this answer plus this one will be the area of shaded region. The area of the shaded region is the sum of these three answers. And to find the area, it is half into pi r square. Pi r square by 2 or half into pi r square. All right. since this time consuming, children, I want you to work this in the class, in the next class. I'll just skip this. I just want to do something else. I just want to do more in less time. So we'll just come back to all this in the next class. Yeah, this one I've already explained. Please take the screenshot, complete this along with the assignment. This I've already explained. Please take a screenshot. Complete this with the other, I think 7 questions. You've taken a screenshot, whatever. Complete this as a part of the assignment. Done?
Yes, ma'am.
All right. This also is, children, similar. We have already understood the situation earlier, so you can do this yourself.
Done, ma'am.
Yeah. This one also, children, believe me, I've already explained this. Navya was not there in that session, but I think I've shared all the recordings.
Ma'am, I saw the lectures, ma'am.
Ah, okay, good. So this is already explained, children. Take a screenshot. And children?
Yes, ma'am.
Okay.
Yes, ma'am.
All right. Yeah. In this one, okay, maybe this I'll give you as a test in the next class, these two, one, yeah. That's all. Only till here. Only till this one, children. This and this we'll do in the next class during the session. Now coming to this figure. So find the area of the shaded region. The shaded region is the region outside the design, but inside the square ABCD. The quadrilateral is a square ABCD, because you can see that the adjacent sides are equal, 14, 14. 14, 14, so it's a square. Now we need to find the area of the shaded region, meaning the region which is inside the square but outside the design. Outside the design. All right. Now the area of the shaded region is the area of the square minus the area of the design in the middle. Area of the square minus the area of the design in the middle will be the area of the shaded region. Now to find the area of the design in the middle, we need this one is a square. We need to find the area of the square and the area of these semicircles and the area of these semicircles. The area of the shaded region is actually the area of the square, 14 into 14, minus the area of this design in the middle. And to find the area of this design, you need to find the area of this square and the area of these 4 semicircles. All this put together will be the area of this design. So that means to find the area of the semicircle, you need the radius. To find the area of the square, you need its side. So you need to find all that first. To find the area of the square and the area of the semicircles, you need the side of the square and the radius for the semicircles. So we'll find that first. Now, what do you call this line segment, children? From the center, that is this line segment. I'm just taking the midpoint of the line segment.
Radius, ma'am.
This is the radius, correct. This is the radius. What will you call this line segment? Is this equal to this one?
To the side. Yes, ma'am.
No, is this one equal to this one?
Yes, ma'am.
Yeah, so what is this one for this semicircle?
Diameter, ma'am.
So that means diameter. So that means this length is 2r, right?
Yes, ma'am. Yes.
Yeah. Then what is it from here to here?
Radius.
Radius. So let me come again. Now this length completely is 14 centimeters. This length is 14 centimeters because you can see it below, it's 14. This length is 14. So 3 plus r plus 2r plus r plus 3 is equal to 14. This is 3. This is r. This one is r. This one is 2r. This one is r. Plus 3 is equal to 14. When you work this, you will find the value of r. Once you find the value of r, you know that these 4 semicircles put together make 2 circles. Make 2 circles. So you can find the area of the 4 semicircles as area of 2 circles, 2 pi r square. And then to find the area of the square, the side of the square is nothing but the diameter. Once you find the radius, the side of the square is the diameter. See, it's the diameter. The side of the square is nothing but the diameter. So you have that also. So find the area of the square. So now the area of the square plus the area of all these 4, that is 2 circles, will be the area of the design in the middle. So 196 minus this area will be the area of the shaded region. So you can complete this one also, children, as a part of the assignment. Take a picture. Yeah, sorry, children. I had to attend to somebody here. Yeah. Yeah, taken a picture, children.
Yes, ma'am.
Yeah, and that instruction pi is equal to 3.14. Don't miss to see that. Pi is equal to 3.14, not 22/7. Yeah. Yeah, read the question and tell me how to find the area of the shaded region. That is the expression. This plus this plus this. Just the expression I want. We'll construct a formula, no? Based on the situation, we'll construct a formula. I want that formula.
Ma'am,
Yeah.
read the area of two circles plus the area of square minus the area of the two sectors.
Correct. Very good. Correct. Yeah. Any other idea? Correct, Navya. Yeah, think. Can it be done in a more simpler way? Not in a more simpler, in a simpler way, without having to subtract anything, simply adding a few things. Can that give us the area of this shaded region? Without having to subtract anything. Simply this plus this plus this.
Yes, ma'am. By using the major sector codes.
Yes, Raja. Yeah, I want that. Yeah, tell me.
Ma'am, by the major sectors of the circles and the area of the square.
Very good. Yeah. Nice. Very good, Raja. Navya, your idea was also good, but you can do it like this without subtracting. So, area of the square plus the area of this sector, plus the area of this sector, plus the area of this sector, plus the area of this sector. Area of the square plus the area of this sector plus the area of this sector. Now we know this corner is 90 degrees. So this angle will be how much, Raja? This angle?
Ma'am, 270 degrees.
270. This also will be 270, this angle. The angle in the major sector. The angle in the major sector is 270 degrees because here it's 90. So 360 minus 90, 270. So the area of the major sector. See, this one is a major sector because radius, arc. The major sector. 270 by 360 into pi r square will give us the area of this major sector into 2 will give you the area of the two major sectors. Find for 1 into 2 will be the area of the two major sectors plus the area of the square. So area of the square side is 28 centimeters. What will be the radius of the sectors? What's the radius for the sector?
14 centimeters, ma'am. 14
14.
centimeters.
Correct. 14 centimeters. 14 centimeters. Sector angle is 270, children. Don't write 360. If you want to use a formula 360 minus theta, you must write 360 minus 90. You must write 360 minus the minor sector angle. The minor sector angle. 360 minus the minor sector angle. If you're writing 360 minus theta by 360 into pi r square, it is 360 minus 90 by 360 into pi r square. You can directly write 270. 270 by 360 into pi r square will be the area of one major sector into 2, the other one, plus the area of the square. Yeah. Please take a picture. Done, children?
Yes, ma'am.
Okay, so this we have to take up in the next class. Please hold on. Just 2 minutes. Yeah, this one. We'll just discuss this. This is a part of the assignment. You've already taken a screenshot of the question and the answer. We'll just discuss this one and wind up the session for today. Yeah. I didn't understand the information given. I'll ask you a few questions. Okay. Now, in a rhombus, tell me if I'm right or wrong. In a rhombus, opposite sides, only opposite sides are equal. True or false?
False.
False. What's the correct statement? In a rhombus,
All sides are
all the sides are equal. In a rhombus, all sides are equal. Okay, very good. Now, what is OQ for the rhombus?
diagonal.
Oh, yeah. So for the rhombus, OQ is one of its diagonals. What is OQ for the circle? Radius. Okay. Now, what is OP? Okay, we're just trying to understand the different line segments in the figure. For the rhombus, OQ is one of its diagonals. For the circle, OQ is radius. Now, what is OP for the what is OP for the circle?
Radius.
Radius. What is OP for the rhombus?
Side.
But we understood that all the sides are equal, right? In a rhombus, all the sides are equal. So if OP is a radius, supposing 5, okay, OP is 5. We'll just say OP is 5. Then how much is PQ? In a rhombus, all the sides are equal, right? In a rhombus, all sides are equal. So if OP is 5, how much is PQ?
5.
5. How much is QR?
5.
And how much is OR?
5.
And how much is OQ? OQ is a radius. It's a diagonal for the rhombus, but it's a radius.
5.
So what kind of triangle is POQ?
Equilateral.
What kind of triangle is OQR?
Equilateral.
Equilateral. And what's the formula to find the area of an equilateral triangle?
Root 3 by 4 a square.
Root 3 by 4 into side square. And what is the side here? The radius itself. What is the side of the equilateral triangle here? It's the radius itself. So root 3 by 4 into r square. Or you can write side square and then side is the radius. You can write side square also, children. Okay, you can write side square. Root 3 by 4 into side square. Now this into 2, no, is the area of the rhombus. There are two equilateral triangles. The rhombus here in this figure, the rhombus is made up of two equilateral triangles. So the area of one triangle is root 3 by 4 a square. Another one, 2 into root 3 by 4 a square. Now this one is equal to the area of the rhombus, which is equal to 32 root 3. So when you work this, you will find the side or the radius of the circle and hence find the diameter.
Ma'am?
Yeah.
Ma'am, can we use the formula to find the area of the rhombus as half into d1 into d2?
Okay. Yes.
If you use that, we'll directly get the diameter.
No, diameter you cannot get. If you use it directly, you will get the
Oh, yeah, no, yes.
I'll just repeat this. So supposing OP, the radius OP, supposing it is 8 centimeter. The radius OP is 8 centimeters. Now this one is a rhombus. All the sides are equal. In a rhombus, all sides are equal. So if OP is 8, PQ is also 8, RQ is 8, OR is also 8. All the sides are equal. Now OP is a radius which is 8. So OQ is also 8 because that's also the radius of the circle. So from this we understand that this rhombus is made up of two equilateral triangles. This particular rhombus is made up of two equilateral triangles. So to find the area of this rhombus PQRO, to find the area of this rhombus, we can use the formula 2 into root 3 by 4 into side square. Because one equilateral triangle is root 3 by 4 into side square, two triangles, so into 2. Now this will give us the area of the rhombus, which is given to be 32 root 3. So you can see that the only unknown in this equation is side. So you can find the side of the rhombus. So you'll get the side of the rhombus. And the side of the rhombus is nothing but the radius here. The side of the rhombus is nothing but the radius of the circle. So double it to get the diameter. Yeah, you've already taken a picture here. That's what is explained here, children. You've already taken a picture. Yeah, class, use the emoji, raise your hand. See, now 12 has become 8. So we have Arjun, Madhumita, Raja, Rajit, Navya, Florentina, Krishmi. Ranjan, are you there? All right, children. So that's it for today's session. Thank you so much, children. You may leave the call. Good night.
Thank you, ma'am.
Thank you, children. Good night.
Thank you, ma'am.
Thank you.